when two vectors are multiplied together, and in the end, the result tends to be an ordinary number, typically a constant value, then the process of multiplying those two vectors is called dot product, which is sometimes known as a scalar product. So, what and what do you need to be familiar with? You need to be familiar with two formulas while dealing with problems involving scalar product. And these are the formulas. If A is a vector, then the product of A, which is A dot B, that is often used, will be equals to the magnitude of vector A multiplied by the magnitude of vector B, then multiplied by the cosine of theta, where theta is the angle between vector A and vector B. This is not everything. You need to know more about these formulas, as they help us to deal with many other problems involving vectors. If that is the case, let's try to analyze some basic concepts that is associated with the dot product. So let's begin by analyzing the result of a unit vector I multiplied by itself. I would like to show you the plane representation of each of the unit vector I, j, and k. So they are three-dimensional plane figures or plane surface that will look something like this. So we can actually call this the z-axis, and this is the x-axis, and this is the y-axis. There's not a specific order or pattern at which we need to select the axis. We can select them randomly. So this is absolutely okay. Okay, perfect. So if this is the x-axis, then definitely the unit vector along the x-axis will be I. So for instance, if this is just 1 unit, okay, let me make that properly. This is just 1 unit. So that is I. Now if this is the y-axis, this will be j, just 1. This will be j. And this is the z-axis. And if this is just 1 unit, this will be k. Perfect. Now I want to find the product of the unit vector I being multiplied by itself. What will be the result? Now, it turns out that the result will simply be the magnitude of the first vector, which is this. However, the magnitude of the vector will be 1, because we said for every unit vector, their magnitude will always be 1. Similarly, the magnitude of the second one will still be 1. Now, what will be the angle between them? Since the unit vector I is parallel, then the angle between them will be 0, cosine 0. And this will eventually become nothing but 1. Similarly, this will also apply to j times or multiplied by j. This will simply be nothing but 1 multiplied by 1 cosine 0, which is simply be 1. And lastly, k times k will also be nothing but what? 1 times 1 cosine 0, which will eventually become 1 as well. Now, we are trying to multiply two similar unit vector. What if we multiply two different unit vector? What would have been the result? Let's try to look into that. What would be the product of the unit vector I and that of j? First, their corresponding magnitude will still be 1. However, judging what we are seeing in the diagram, each of the axes tends to be perpendicular to themselves. So definitely, okay, did I get that properly? Definitely, the angle between them is 90 degrees. So multiplying I and j together as a unit vector, then the angle between them will be 90. But unfortunately, the cosine of 90 is indeed equal to 0. So eventually, I times j will be 0. This also applies to I times k, which will be 0. Similarly, j times k will also be 0. In fact, k times j will be 0. Once you multiply two different unit vectors together, they will eventually become 0. So, what conclusion can we actually draw out from this analysis? Well, what you need to keep in mind is that we can actually prove that two vectors are perpendicular once we can show that their dot product is indeed equals to 0. And at the same time, we can actually at the same time prove that two vectors are parallel once their dot product is indeed equals to 1. And this is something you want to keep in mind. Whenever a problems involving dot product include something like being parallel to each other, then you know that their dot product will be 1. And whenever it includes perpendicularity, you should know that the dot product will be nothing but 0. Perfect. Now, is there another thing that is attached to dot product that you need to be familiar with? Yes, there is. And what exactly it is? And here it is. Now that since we already know what the product of these unit vectors are, let's try to consider two vectors, A and B. If A is given as x sub 1I plus y sub 1, j plus z sub 1 k, and B is also a vector and is given as x sub 2 I plus y sub 2 j plus z sub 2 k. If I'm to multiply A and B, it's not that will be nothing but x sub 1I plus y sub 1j plus z sub 1k, then multiply by x sub 2I plus y sub 2j plus z sub 2k. Now let's expand this bracket and see what we're going to have makes sense. So let's begin with x sub 1I. We are distributing it for each term respectively. And that will be x sub 1I times x sub 2I. That's x sub 1I, okay, x sub 2I. X sub 1I times y sub 2j. That's plus x sub 1I y sub 2j. This times this, that's plus x sub 1I z sub 2k. Perfect. Now we are adding this. Now let's move to the next one. Y sub 1j. Now the y sub 1j multiplied by x sub 2I. X sub 2I. Similarly, y sub 1j, y sub 2j plus y sub 1j, y sub 2j. And the last one plus y sub 1j, z sub 2k. And we're adding this to that of z sub 1. Z sub 1k multiplied by x sub 2I. Then z sub 1k multiplied by y sub 2j. Lastly, z sub 1k, z sub 2k. Perfect. Now, let's see if there's something we can get here. There's more actually, not just something. Now, this is I times I, and we were able to show it earlier that I times I is nothing but 1. So this is being simplified to this. I'm trying to create more space. So vector A dot vector B is now equals to x sub 1, x sub 2. Now, this is I times j. Two unit vectors that are different will become 0. This is I times k. Two unit vectors that are different will affect this, or to become 0. j times I becomes 0. Now, j times j becomes 1 plus y sub 1, y sub 2 becomes 0. J times k times I becomes 0. K times j becomes 0. K times k becomes 1. So plus z sub 1, z sub 2. And this is it, which implies that if you have two vectors that are defined on a three-dimensional plane surface and you are required to compute the dot product, all you need to do is just to multiply the corresponding coordinate values together and you have your final answer. Keep in mind, while dealing with problems involving dot product, your result must be ordinary number and not a vector anymore. So let's consider some examples to see what we are seeing in exercise. Number 1. Let's find the dot product of these two vectors. Vector A is defined as this: 3i minus 2k plus 4. Oh, okay, sorry. G. And vector B is defined as 2i plus 3j and minus 5k. So what would be A dot B? Simple. 3 times 2, that's just 6i. However, the I will become 1. Then negative 2 times positive 3, that's negative 6. Then positive 4 times negative 5, that's negative 20. So final answer is indeed equals to minus 20. And that is the dot product. You can see how straightforward that is. Just multiply each of those components, corresponding component values, and add them up to have a final answer. And that's it. Hopefully you find that helpful. Let's consider more examples. But before we go into that, there's something I almost forgot, which I would like to disclose with you. Earlier we talked about the dot products to be defined as this. Now, what you need to keep in mind is that if the problem you are dealing with involves angle, then you can always use this to determine the dot product. If you are asked to do that, just find the magnitude of A of the first one, magnitude of the second one, and multiply it by that vector. And if that problem involves parallelism or perpendicularity, it still involves angle. You just need to know that it's not necessary for the angle to be mentioned. Once it is parallel, the angle between them will be 0. When they are perpendicular, the angle between them will be 90. It's only when they mix an angle of a certain unit together, that's when the angle will be specified. Now, if the angle between them is not specified and you can't figure out any word like parallelism, perpendicularity, then I would recommend you should use this to find the dot products. Please always make sure you keep track of that. So let's continue with our example. Example 2. Find the angle between the two vectors. A to be defined as I plus 2j plus 3k, and B to be defined as 2i minus 3j plus k. So how can we find the angle between them? That might take a little bit more time because we are still going to be using this formula. So what we're going to do first is to divide both sides by the product of the magnitude of those two vectors. And doing that, you can clearly see that we will have this. This cancels out, and cosine of the angle between those two vectors becomes A dot B divided by their corresponding product of their magnitude. So after that, let's just find the cos inverse, the arc cos of this right here. We have the angle between them. So that is where we are going next. So let's begin. So let's compute the product of those two vectors. So I times 2I, that's just 2, positive 2j times negative 3j, that's negative 6, then positive 3 times positive, positive 3k times positive k, that's just positive 3. In the end, the dot product is negative 1. Now, what will be the magnitude of vector A? That will be nothing but the square root of 1 squared plus 2 squared plus 3 squared. Sum the squared of the component of each of the vectors in vector A. And that will be the root of 1 plus 4 plus 9, which is the root of 14. What about the magnitude of vector B? That will be the root of the square of this, which is 4, plus the square of this, which is 9, plus the square of 1, which is 1, which is still the same thing as the root of 14. Perfect. So now we can determine the angle. Cosine theta is equals to a dot b, which is negative 1, divided by the product of the two vectors, the root of 14 multiplied by the root of 14. And that will be eventually be negative 1 divided by the root of 14 times root 14. That will be nothing but 14. So what will be negative 1 divided by 4? So I will need to use my calculator for that. Okay, I got negative 0.0714 and so on. So the arc cosine of this value will be what? Theta will now be the arc cosine of negative 0.0714. So that will eventually be 94.1, which is the angle between those two vectors. And that is it. That is it for this problem. Let's consider one more problem. In fact, this time around, let's look into what problems. Find the value of x and y if u is a vector and it's equals to xi plus 2yj minus 3k. And this vector u is perpendicular to both vector v, which is defined as 2i minus j plus k, and that of vector w, which is defined as 4i plus 2j minus 4k. Feel free to pause the video and check this question out yourself. So first, we need to understand that vector u is perpendicular to both v and w. And if that is the case, the product of vector u and that of vector b must be indeed equals to 0. Similarly, the product of vector u and that of vector w must also be equal to 0. Why? Because for two vectors to be perpendicular to each other, then their dot product will be nothing but 0. If that is the case, let's see if we can formalize anything. Let's begin. What will be u times v? And that will be xi plus 2yj minus 8k, then multiply by 2i minus j plus k. So xi times 2i, that's just 2x. 2yj times negative j, that's just negative 2y. And negative k by root x. Oops. Negative k, 8k times positive k, that's negative 8. And don't forget, that product will be 0. And that will be equal to 0. So in the end, 2x minus 2y will be equal to 8 by the time we add it to both sides. Perfect. Let's keep that somewhere. Now, what will be u times w? This will be nothing but xi plus 2yg minus 8k, then multiply by 4i plus 2j minus 4k. Perfect. So their product will be nothing but xi times 4i, that's just 4x, then 2yj times 2j, that's just positive 4y, then negative 8k times negative 4, that is positive 32, equals 0. So 4x plus 4y equals negative 32. By the time we subtract 32 from both sides, and we have the second equation, u times w equals 4x plus 4y equals to 32, negative 32. And that is it. Now we have simultaneous equations which we can solve systematically. So I'm going to stop here for this video. Feel free to solve for the value of x and y. Let me know their corresponding value in the comment section below. Thanks for watching. See you guys in the next video. Bye for now.